Find all rational zeros of a polynomial function. We're going to start with the polynomial function f of x equals x cubed minus 2x squared minus 13x minus 10. We're going to do this in 3 steps. Our first step is going to be to list all the possible rational zeros. Then we're going to find them. Then we'll factor f of x into linear factors. Once you find the rational zeros, the linear factors is a whole lot easier. So let's go ahead and get started. So again, our polynomial function here, f of x equals x cubed minus 2x squared minus 13x minus 10. And we are going to find the possible rational zeros. So that is our first step. Now you might recall that finding your possible rational zeros is taken by the factors of p over the factors of q. And if you don't remember what those are, the constant term is referred to as p and the leading coefficient is q. So with p, we think about negative 10. What are all of the factors of negative 10? Well, we can multiply 1 times negative 10 or 10 times negative 1. So we're going to have plus or minus 1 and plus or minus 10. Also 2 times 5, with one of them being positive, one negative. So plus or minus 2, plus or minus 5. We have 8 options for our numerator, right? 1, 2, 5, and 10, each one of them a positive or a negative. In the denominator, our leading coefficient is 1, so we just have plus or minus 1 in the denominator. You've got to love a leading coefficient of 1 because when you divide by 1, nothing changes. So essentially, our possible factors are 1, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. That's part A. Check. Now, part B says, let's go ahead and find these zeros. So we're going to try. We're going to take these 8 options and we're going to plug them in until we find the one that works. Now, you can use synthetic division if you'd like. You can also use the remainder theorem. Because remember, the remainder theorem says if we try, let's say, f of 1, if f of 1 is 0, then 1 is a 0. So let's try that. Let's try 1. So if I plug 1 in, I get 1 cubed minus 2 times 1 squared minus 13 times 1 minus 10. So I get 1 minus 2 minus 13 minus 10. Oh no, that is not equal to 0, so this does not work. Okay, let's try the next one. I always start with my smaller numbers because I want to easy as possible. So let's try negative 1. So I'm going to have negative 1 cubed minus 2 times negative 1 squared minus 13 times negative 1 minus 10. Okay, negative 1 cubed is negative 1. Negative 1 squared is 1, so negative 2 times 1 is negative 2. I have plus 13 minus 10, and that does equal 0. So that means negative 1 is a 0. Okay, that's good. That is like, woo! Now that we know negative 1 is a 0, we can use synthetic division to figure out what's left. Basically, we're factoring out that x plus 1. So we can say, okay, to do synthetic division, we take down our coefficients of our polynomial function. So 1x cubed, negative 2x squared, negative 13x, and negative 10. Okay. And we know that negative 1 is a 0. So our k value on the outside is negative 1 because we know it works. So when I do my synthetic division, I bring down my 1. I multiply on the outside. I add on the inside. Multiply on the outside, add on the inside. Multiply and add. And we know that this has to be 0 because we know negative 1 works. So now what do I have left? I have x squared minus 3x minus 10. Because remember, after synthetic division, our exponent drops down by 1. Hopefully you see this and go, oh yeah, this factors to x minus 5, x plus 2. So I know my 0 is 5. And negative 2. So part B, listing my zeros, I know that we have negative 1, 5, and negative 2. Woohoo! Great. Now that we know our zeros, we can factor this. So again, my zeros are negative 1, 5, and negative 2. Well, think about what that means. That means x plus 1 is going to be 0, right? That's the negative 1 that goes in. If I have 5, that's going to give me x minus 5, because when I plug in 5 for x, I get 0. And then x plus 2. So this is the idea. You kind of notice that the sign inside is opposite of what you see. Okay, so we'll end up with f of x equals x plus 1, x minus 5, and x plus 2. And that is the factored form of our original x cubed minus 2x squared minus 13x minus 10, with our 3 zeros found from using the remainder theorem and then synthetic division.